Okay, now we're going to talk about changing the variable, or sometimes it's called the substitution method. Changing the variable, or sometimes we call it the substitution method. Okay, so we're going to start off by looking at a question. Limit x approaches 4 of x minus 4 over root x minus 2. Now, before we get all up in arms, I could do this question simply by doing a difference of squares on the top and factoring it out. I could be done in 2 seconds. Do you agree? Yeah, I'm getting some nods. I could also do it by rationalizing the denominator. Okay, so just because I could do it those ways doesn't mean I should. I'm going to do it a different way so I can show you something, and then I'm going to do another question that really benefits from this method. This question does not benefit from this method. If I came across this question walking home, I'm walking home one day, some troll jumps out from underneath a bush. I don't know why it's always a troll, but it is. A troll jumps out from underneath the bush and says, "Hey, buddy, figure out this limit now." Well, I would sit there and say, "Oh, okay, Mr. Troll." See, you always be very respectful for trolls, especially if they jump out from underneath bushes. And I would make this a difference of squares. And I would say, "Mr. Troll, your answer is 4. And I would be done. And the troll would be happy. And life would go on. But I don't want to do it that way. No, sir. I want to do a different method. And I'm going to use a substitution method. And when I look at this, I notice that the thing that's giving me a hard time here, or the thing that's ugly, I don't like to use that word in mathematics, but when you look at this, and the part of this that makes you a little bit uncomfortable looking at it, you have to agree is the root x. It's the thing that kind of sticks out as being, don't really like that guy. So, let's get rid of him. Let u equals root x. Well, that's great. Okay, so I can now replace this root x with u, which is awesome. Except, if I replace that root x with u, I've got an x and a u now. Well, that's not good, right? I don't want an x and a u. I either want all x's or all u's. So if u equals x, doesn't that also mean that u squared will equal x? I'm sorry, if u equals root x, doesn't that mean I can square both sides so that u squared equals x? Okay, so now if I do a substitution, I could change that to u, and I could change that to u squared. That's cool. Very cool, very cool, very cool. Wait. I'm going to have x approaching 4, and I'm going to have u's. Well, that's not good, right? Because I don't want x approaching 4 when I have u's. So I need to know what happens. I need to know, so as x approaches 4, what's u doing is my question. So if x is approaching 4, what do you think u's going to do? So I look back up in here, and I find x. Here's x. Well, here x is here too, but here's u by itself, not u squared. So as x approaches 4, so ring-de-de-ding, this approaches 4, root of 4, this is going to approach 2. So as x approaches 4, as x approaches 4, u is going to approach 2. So I'm going to take this entire question now, and I'm going to write it in terms of u. So it's going to become limit as x approaches 4, no. We want u approaches 2. And x minus 4, no. We want u squared minus 4. And as root x, no. We want u minus 2. And you have now created a brand new question that looks a heck of a lot easier than the other one. And hopefully you would know to difference of squares. Oh, I put an x, no x. And this is my 0 term. Bye-bye. And it's going to leave me with, as u approaches 2, ring-de-de-ding, u is approaching 2. That's going to go to 4. And look at that. I got the same answer. using a completely different method. Now, granted, I don't want to hear this. Yes, it's much easier to do it just by factoring. Yes, you might even consider it easier by doing rationalizing the denominator. But, did you hear the but? But, why don't you try this one on for size? Dun, dun, dun. Now you're quiet, aren't you? Yeah. You're going to try to factor that? You're going to try to rationalize it? Nuh-uh. That's ugly. That's ugly. Okay, so what are you going to do? Well, I'm going to look at it for a minute and I'm going to say, that's ugly. And then I'm going to feel bad for saying that because no math is ugly. It's actually beautiful. It's just, this guy is really kind of bugging me. It just, he's causing me stress. I have to admit, he's causing me stress. So I'm going to let you, not you, but the variable u, this u, I'm going to let you, that was funny guys, you're supposed to laugh at that. You're a hard group, you really are. So I'm going to let u equals x plus 8 to the 1/3 because that's the part that I don't like. Which means that I can go back and replace this with u, which would be great, but then I'm going to have an x. And that's not so great. I don't want u's and x's, I'd like just u's. So I'm going to go back and look at this, and I'm going to rearrange it so I can find out what x is. So I'm going to cube both sides, and I'm going to take 8 over to the other side, and that's going to be x. And that shouldn't be hard to do. That should be fairly easy to do. And so now I'm pretty excited because I can change this to u, and I can change this to u cubed minus 8. But then I notice I've got x's over here, and that kind of, oh, that's sad. I don't want x's here and u's here. I need a u here, don't I? So I have to think, so when x approaches 0, I wonder what u does. So I look up here, well, as x approaches 0, that's hard. That's going to hurt my head. I can't figure that out. Okay, as x approaches 0, ring-da-da-ding, x is approaching 0, 0, 0. This becomes 8. Cubed root of 8 is 2. That means u equals 2. Well, approaches 2. Let's not use the word equals. That's dangerous in calculus. Okay, so guess what I've done? I've created a brand new question that will look like this. The limit as u approaches 2 of u minus 2 over top of u cubed minus 8. And I don't know about you, but all my anxiety has just left the building. I'm just feeling so comfortable with this. It's just a beautiful thing, really. It's a difference of cubes on the bottom. I already know what my 0 term is on the top. I'm feeling so comfortable with life. That's my 0 term. I need to get one of those in the bottom. So I'm going to cheat. I'm just going to write it. I know I got to get it. And I'm wondering what I'm left with. I'll be left with u squared minus 2u plus 4, because I know how to factor a difference of cubes, and if you don't, well, I guess you better learn. And so now my 0 term is the top, reducing with the bottom. I'm now going to allow the limit to take effect. Are you ready? Do you know the sound that a limit makes? It is ring-da-da-ding, ring-da-da-ding. So as u is approaching to, hold on, I think, do I have a mistake here? No, I think I'm good. U is approaching 2. Ring-da-da-ding, ring-da-da-ding. So this is going to be 4 minus 4 plus 4. This is bothering me. I'm not sure this is right, so I'm going to check it. Now notice, again, I really like the fact, I'm not upset that I'm not being perfect here. I'm not sure. This is bothering me. I don't think I remember correctly whether or not it should be 2 negatives. So look what I'm going to do. I'm going to check it for myself. I'm going to expand it. So this is a cubed. This will be negative a squared b. This will be plus ab squared. This will be negative a squared b. This will be plus ab squared. And this will be negative b cubed. So does it work? Negative a squared b, negative a squared b. No, it doesn't. That's negative 2. So this is wrong. That needs to be a plus. Do you see what I just did there, children? I know enough about my mathematics that I can double check what I'm doing. I want that for you guys too. That needs to be plus. Let's see if it works if it's plus now. A times a, yes. That one will be plus a squared. This one will be plus. Okay, so then this one is negative. And then this one is going to be negative, negative. And then this one is going to be negative. Does this work now? A squared b. A squared b. Yes, they're gone. AB squared. Oh, yeah. It does work. Isn't that grand? Not having to memorize something and not goofing up because you can't figure out if you did it right or not, but you can put it together. I think it's grand. So anyway, so what do I get? 4 plus 4 plus 4. I think it's 12. And I think I'm done. All right, kids, I'm going to post your